We have Saurabh Harit here. He's a managing security consultant at Spirent. He says here he's got a secret crush on binary reverse engineering, which is probably true of many people in this room. He's worked on proof of concept exploits, white papers, and so on. And he claims to know what you installed last summer. Over to you, Saurabh. Thank you.
Thank you. Hi, everyone, and welcome. I am Saurabh Harit. I'm managing consultant at Spirent Security Labs. Today, I'm going to be talking about some of the common DevOps mistakes and misconfigurations and how and what their consequences could be from a red team or our penetration tester's perspective. Yeah, there's nothing much to me. I like reverse engineering, but I don't do it on a regular basis. But I like to reverse engineer stuff every now and then, simply because I started my career as a reverse engineer. I'm a red teamer or evolved penetration tester, and that's where my interest lies these days. And I'm based out of Canada, so I'm always shivering. Right, so these are some of the things that we'll talk about. What are the common DevOps failures, why they are common, and sort of like why we come across these things often, and what could go wrong with these kind of misconfigurations. What could be the impact of having those simple mistakes or simple misconfigurations on a corporate network, and how to detect and mitigate those particular issues and stay secure. Right. Let's talk about a scenario. So for example, if you're a penetration tester or if you're an actual bad guy and you've broken into someone's office, so you've bypassed physical security or you're a red teamer. So at that point, a particular time, you really don't have a lot of time. So you just want to find certain vulnerabilities, exfiltrate data, and move out. Right? So in that particular situation, or even if you're doing a penetration test, but you want to be stealth, right? So setting off a generic vulnerability scanner like Nessus or a port scanner would definitely be really, really noisy, because especially a generic vulnerability scanner like Nessus sends out thousands of requests per second. So if there's a blue team or even a vigilant network administrator, they'll be able to catch you. A lot of companies also have different solutions, like they have NAC implemented, they have they're checking threshold on their Ethernet ports. So like something like Nessus would definitely be blocked in a matter of seconds. Right. So some of the challenges in that situation is what I just talked about. We can't really use a network vulnerability scanner because they're too noisy. We have to be stealth. We have to be quick. And so like one of the things I wanted to mention was the approach that I'll talk about in this particular presentation is just one approach. All right? I'm just looking at different DevOps misconfigurations. And there could be many other approaches, parallel approaches that you could take on a particular network to compromise it. You don't really use Google Docs. So how many of you heard of Google Docs? Right? So Google Docs are basically different directives that you can use in Google. So for example, if you use site www.spirent.com, it will give you all the links that are related to spirent.com. Right? If you use link directive, so link www.spirent.com, it'll come back with all the results that have link to spirent.com. So for example, a job site, Spirent acquired another company, so they would have a link to Spirent. If there's a news about Spirent, a news website might have a link to Spirent. So all that, so you can use all these directives to sort of passively find information about an organization, especially when you are in a recon or open source intelligence phase. These passive techniques might help you to maximize your target, right? So like I'm after Spirent.com, but Spirent may be like a very security-focused company, so and they have a lot of tightened perimeter security. But using these links, I found out that Spirent recently acquired a company called abc.com, which is a music company, and they're not that security savvy. But the abc.com may have an internal link to Spirent.com, so an attacker would start going after abc.com, compromise them, and then find a route to Spirent.com. But we can't use these directives, especially when you're an internal network, because they're not publicly exposed systems. Why? Because a lot of the misconfigurations that I'll talk about, they can have grave consequences. It may look like a simple mistake or a simple installation, but that can lead to the compromise of the whole corporate network. In IT, we like to install stuff. I do that myself. And a lot of these times, that particular installation is just meant to be temporary. So you wanted to try something out, see how it works. So you'd install it, test it out, but then forget about uninstalling it or securing it in the proper manner. So these instances are often left on the network unsecured, which could be dangerous. Right, so it's not 1980s anymore. So a lot of technology has developed. So like the IPS, IDS, they have really matured. Firewalls have matured. The network admins are more security conscious now. So they're implementing better security and on the application and network level. So we often go back to, so as a red teamer, as a pen tester, you often go back to a simple question. It's not about what, it's about where, right? And that is key because you're always looking for that one weakness. And this is basically where the challenge comes for a blue team or the defenders. Because as an attacker, you only need to find one way in. As a defender, you have to defend all the doors, right? So you can, so attackers can keep saying that the security was not up to the standards, but you often fail to understand the challenge that is faced by different defenders. Right? And as an attacker, there might be multiple doors that would be locked, but you only need to find one weakness or that one window of opportunity. Right, and so I'm going to talk about that, finding that one window. And like I said, there could be multiple ways. So when you are on the internal network, you can exploit different things. Like you can perform LLMNR, net bias, name server poisoning. You can do password spraying. You can see if there's null session allowed by a domain controller and go from there. So there are multiple paths to it. And this is not the only path, but I'm just going to talk about applications that are installed, often found on the network. And I'll start off with some of the popular applications that are usually installed on the network. So, for example, Apache Tomcat is a web server application or a servlet container. It lets you deploy your own application. And I've done thousands of pen tests. And Apache Tomcat is something that I pretty much almost always find on a network. And it's almost always configured with a default username and password. And I've started to believe that Apache Tomcat sort of installs itself on the network. And even if someone tries to secure it, it reverts back to the default password for some reason, because it's always there. There was a customer I used to do pen test for them at least thrice a year. And then for the first time when I went in, I found an instance of Tomcat. It was configured without any username and password. So I got access to it. I compromised the backend server and compromised the whole network from there. I went back the next quarter. It had the username admin and password admin, so I did the whole dance again. Went back the third time. This time the username was admin. The password was not admin. But I did some more digging, and the password was !admin. So you do the whole thing again, and yeah. Right, so one of the things that Tomcat allows you to do is that it lets you deploy your own applications. So you can create a Java package, a jar file, and deploy application. And as a penetration tester, you would create like a web-based command prompt and then upload it. And once it's uploaded, you can access it and then use it to run commands with the privileges with which the Tomcat is running. If it's running as a low privilege user, you'd probably have to escalate privileges to local administrator or system. If not, if it's already running as local administrator, then you can do all those fun things like extract password hashes for local users, use something like Mimikatz to extract plain text password from LSAS, so on and so forth. The other common application that you find is JMX. JMX also lets you deploy different applications. So In fact, like there are several vulnerabilities in JMX that lets you deploy applications. So there is a module called File Deployment Repository that lets you deploy your own application, and then there are many other modules that lets you do the same. And it's, again, the same thing. When you have the ability to deploy an application, you can deploy a web-based command prompt and then execute commands on the system. You can create your own username and password and then just directly RDP onto the system or connect via WinEXE, dump passwords, so on and so forth. Third application I will talk about is Hudson Jenkins. It's also fairly common and found on the network. A lot of times, it's, again, configured with default password or no password. But Hudson Jenkins has a script console. So here at the bottom. There's a URL manage/script, and then you end up in a script console. And basically, it allows you to write different Groovy script or JavaScript and then execute it, right? So you can write a very simple Groovy script, it's like a 4-line code that, again, allows you to do command execution. So it takes that command, executes that code, and gives you the output in that particular console. Other than that, I've seen that you can also browse through the build history that's on the top left here. And then you will see that there are different test scripts that are loaded. And a lot of times, they're not well filtered, so you can find credentials in there in plain text. So again, a very easy access to a backend operating system. You might get an idea where I'm going with this. So I'm going to specifically talk about applications that allow you to compromise backend systems, right? And these were some of the common applications that we just looked at. And these are what the shells look like. So here at the top, this is the script console from Hudson Jenkins, right? This is like a 5-6-line code that I wrote. And then here, I've specified a command. So net user, username, password, add. And when I hit submit, it'll execute that command, and it'll add my users. So my obvious next command would be net user, username, net local group administrators, username add, which will add my newly created user to the local administrators group. And obviously, it will depend on if this particular application is running as a local administrator. And even if it's not, then I have other options. So I can browse file system. I can look for secrets on the file system, if there are any passwords on the file system, any other sensitive data, so on and so forth. This is what looks like when you deploy a malicious application through Tomcat. So in this case, it was particularly a simple command.jsp, which mimics a web-based command prompt. So here you can enter your command, and in this case, it was who am I, and it'll tell you the output right there. So it gives you an ability to execute code on the backend system. Right. And so like I said, these are some of the common applications that we looked at. I'm just going to quickly talk about some of the not so common applications that are also found on the network. And this is an application called AD Manager Plus. It's a third-party fancy application to manage your Active Directory. So it provides you with a very nice web console and lots of other functionalities. Yeah, it connects to the Active Directory. You can create users. You can change passwords, so on and so forth. This was my quickest domain admin, thanks to this particular application. I was at client side during an initial kickoff call, and while I was connected to the Intel network during the kickoff call, I was out of curiosity looking for different applications, and I found AD Manager Plus installed. It was configured with default username and password. So I created a domain admin right then and there, and the project was over during the kickoff call. So here I created a username, password, added it to domain admin group, and it was all done. And when I came back the next day, this application was gone. And so it turns out someone from the IT team had installed this application because they wanted to try it out and see how it works, but they did not configure it with a strong password. So pretty much all these applications come with default password, and we often don't change it. However, to my cause, I had already created a domain admin account at that point of time, so it didn't matter if the application was gone. This is another application that I came across. I was doing an external network penetration test, and this was exposed over the internet. This is a CyberOhm UTM, which is Unified Threat Management. And at that point of time, I couldn't find anything on the external network that I could exploit. It was all locked down. And then when I was about to give up, I came across this security device web interface. And I found 2 zero-day vulnerabilities in this application and reported it to the customer. They've all been patched now, so I can talk about it. And so the 2 issues I found was that, firstly, there was a remote code execution, so you could execute code remotely through their web interface. But that was not the worst part. The worst part was that they had this test page. So they had this configuration page where you have username, password, domain name, and then domain query, and then test connection, right? So when you click on test connection, or you can just right-click on this page and view the source code of the page. And when you do that, you will see that they are storing the username and the password. So here you see that it's all starred out, the password, but it's actually there. So like they're bringing the password to the client side and storing it. And you just right-click on the page, view source of the page, and then you can see the actual password in plain text. And because it's a security device, these are often configured by high-privileged domain users. So a normal user wouldn't configure them. So most likely, a high-privileged admin user, most likely domain admin. And so just like that, you will get access to a domain username and password, domain admin username and password. The only other thing that was open on the network was SSL VPN. So I took this information, connected to the internal network, and just gained privileges from there. So, and I didn't even know what to tell the client at that point of time, because what do you tell them? So if you can just get rid of the security application or security box, you will be fine. Right, so the other next question that comes to mind is that, fine, I've installed the application, it's a dev environment. What's so wrong about it? And so there are a few issues, because it's not supposed to happen. It's not an ideal situation, but data is often replicated. So if there's a database in the dev environment, it will most likely have data from the real database, because you're doing testing on that data, and you need data. That data might be outdated, but it's still production data a lot of time that ends up in the production databases. Domain segregation is really hard to achieve, from what I've learned in ages. So a company may create different domains. So there may be a dev domain, there may be a test domain, there may be a finance domain, and then your user domain. But to segregate domain, really segregate it, it becomes very difficult. So unless you have dedicated team for each domain and there is no overlap between teams, it's often easy to just exploit the domain trust relationships and move from one domain to the other. For example, if I am a domain administrator and I manage all 4 domains, a lot of times I will end up using the same password for all 4 domains. So if you compromise one domain and you extract the password hash for me, you can replay it on other domains, and it might work. So I was on a penetration test where, you know how we talked about the first 3 common applications, Tomcat, Jenkins, Apache JBoss, and these are the common applications. If you've been a penetration tester for a long time, you probably look for such applications on a network and try to exploit them. But sometimes these applications are not installed, right? So I was on such similar pen test. I couldn't find any of these applications on the network. And so I started looking at different ways of finding similar applications that basically allow you to compromise the backend system. And at the same time, I also wanted to learn Ruby. So I started writing this framework. So basically, Yasuo is a framework that automates the task of finding similar kind of applications that allow you to compromise the backend system. Now, Yasuo is not a web application scanner. It's not a vulnerability scanner. it just scans for already known vulnerable applications. So there are like tons of already known vulnerable applications, third-party applications, and Yasuo is just a framework to find those applications. This data has been updated. I think currently we support around 150 applications that it finds. And yeah, like the whole purpose was that I started going through exploitable, which basically is a database of which contains different vulnerabilities in different applications, operating systems. And I found out that if I filter out vulnerabilities like cross-site scripting, cross-site request forgery, and only look for vulnerabilities that like remote file include, local file include, remote code execution, file upload, which basically allows you to execute command on the backend system and compromise them. There are almost 12,000 similar applications, and you can't remember each and every one of them because I know Tomcat is a popular one, but like there are other applications out there which allow you to do the same thing, which was the motivation behind writing Yasuo. Because remembering all this and testing it out manually is a pain. You don't have time for it. So I just wanted to automate that whole process. There are some similar tools out there, but not quite. There is Nikto, there is Nmap script. But what these tools do is basically take up a URL, find different folders, find different files behind them. They're not specifically looking for vulnerable applications, while Yasuo is specifically looking for applications which are already known to be vulnerable and are already there in exploitable. This is a simple command line that Yasuo comes with. So the core of Yasuo is the signature file, which is a YAML file, which contains unique signature for different applications which are vulnerable. And I'll walk you through the YAML file in a bit. It can accept two different kinds of input. It can accept a file with IP address, a new line separated file with different IP addresses. And then it can also accept your Nmap output. So if you do a port scan using Nmap and save the output in XML format, it accepts that as well. A lot of other options are standard to what Nmap also has. So like you can specify what ports to scan. You can specify that you don't want to ping the host. You can specify all the ports to scan. And it also has different threads. Finally, there's a brute switch to it. So basically, once it finds the application, you can also ask Yasuo to brute force it. So either that application won't have any authentication, or it'll have a strong authentication or strong password, or it'll be configured with the default or weak password. So in case it has a default or weak password, Yasuo will also brute force that password and let you know the output. This is how the program flows. So you can either do your own port scan, save the output in XML format, and feed it to Yasuo, or you can tell Yasuo to do a port scan for you. And so it does the port scan. It looks for open web-based ports. And then once it finds the open web-based port, it starts to pick up signature from different files, and then start creating and sending requests. Now, you might have come across web servers which just send HTTP 200 OK for each and every request you ask, right? And that's going to be a problem because when you are doing a signature-based check and your web server is responding with 200 OK, so like you ask for a garbage.txt, and it comes back and says that, yes, I have garbage.txt, but that's not really true. It's just configured that way to send OK response to everything, right? And that would create a lot of false positives. So even before Yasuo starts doing application fingerprinting, first of all, it sends out a request for unexisting or non-existing folder, right? And if a response comes back OK, then it also asks for a non-existing file.txt. And if that comes back with OK as well, then it just ignores that particular IP and then moves on to the next one. If you choose to brute, in the end, it'll start brute forcing, and then it'll tell you that, hey, I found the credential for that particular application. If not, then it moves on to the next port. This is what really comes with Yasuo. So this is the main file, which has most of the code. So there could be two kinds of authentication. There could be an HTTP basic authentication, or there could be a form-based authentication. So this file contains the code for form-based authentication. So it performs brute force on a web form. Signature.yaml is obviously the signature file. And then it comes with a minimalistic username and password file for brute force. But you can provide your own username and password file, which could be a more elaborate file. Released under GPL license, so it's free to use, reuse, rewrite. This is what the YAML file looks like. So here we have path 1, which is unique path 1, which could be unique to that particular application. This is path 2, which would be the secondary path to check. There could also be a version string. So if you're looking for a specific version of an application, then we test for that as well. And then exploit path, basically where the exploit for that particular application is in Metasploit or on exploit.db. Behind the scene, it detects false positives. So like I said, it sends a request for a non-existing folder, non-existing file to filter those out. It automatically extracts the login page as long as it is in English. And it automatically extracts the login parameter. It does multi-threading. Right, I have 5 minutes left. Let's do a quick demo. So what I did was I configured 2 virtual machines with certain default applications installed in them for the demo purpose. And then we're just going to test Yasuo out against these 2 different applications. So for the purpose of this demo, I did my own port scan using Nmap, and just to find out what ports are open on that particular virtual machines, and saved it to the XML format. So these ports were open on those 2 virtual machines, and the output was saved in the XML file. And this is what the output of Nmap XML output looked like. So basically, you take this particular XML file and then feed it to Yasuo, and it will start reading the file to extract all the web-based ports that open. So one of the things that you can do is, it's not really a red team stuff because you're still doing port scanning. But what you could do is like do a very stealth port scan, very slow port scan, and then feed it to Yasuo. And then instead of checking for all 150 applications, which could get a bit noisy, you can create your own YAML file. So like just pick 3 or 4 applications that you think may exist on that particular network. And then create a custom YAML file. So in that case, it'll only look for those applications which I've mentioned in that particular YAML file. So here you will see that it starts to pick out all the web ports and then starts to send you a request. So initially, it will find out that, OK, 192.168.112.178 has port 8080 open, which is a web-based port. It is an HTTP protocol, and then it picks up signature, which is /manager/html from the YAML file, and then embeds it, and then sends it to the server. Based on the response, you can tell that, hey, this particular IP has this port open, and on which Apache Tomcat is installed, and here is the link to the exploit. We didn't do any brute forcing at this point of time, but you can enable the brute force switch, and it'll start brute forcing the login for that particular application. It also saves, there's a log folder that is created every time you run it. So it saves all the output in a SQLite database and a log file, so you can refer back to it. So just quickly go. So SQLite database, it's got one table called Vuln Hub, and you can query that table to list all the applications it found at a later point of time. There you go. So it wouldn't have the username and password because we didn't brute force at this time, but it contains all the other information. Just going to fast forward it just a little bit. So in this particular case, I'm going to brute force it, run it again. And so one of the things Yasuo does is that it's got, you can call it smart brute forcing. So what happens is that different kind of applications may have unique logins. So for example, Apache Access has the username admin and the default password is access2, right? So in case you know if an application has a default password, then you don't need to brute force all the passwords. So it starts off with app-specific password, and first it tries the app-specific password. If it finds it well and good, you reduce the noise on the network. If it doesn't, then it starts brute forcing the username and passwords from your user and pass.txt files. Right, so in this case, it did find that the username was Jenkins, password was password123, and then it moves on to the next application. Here in this case, it tries the app-specific password first, and then it found that password, and then it moves on to the next application. Right, so it goes on like that. So one more thing I did was to just make it a bit more stealth is that when it passes through the IP, and the port, different IP may have different ports, there are different IPs. So if you go after just one IP with all the signatures, so first of all, if it starts going after, say, port 10.10.10.1, port 8080, and if it starts doing signature check for that IP with all 150 different signatures, and then starts brute forcing them, you're hitting single IP a lot of times to raise a flag. So what it does is that it randomizes. So it sends a request against 10.10.10.10, port 8080, and then the next request would be to a different IP, different port. So it keeps randomizing different requests, so you're not hitting a single server, single port multiple times, and then it keeps coming back to the other ports. We have robust check for false positive. The output is now formatted. The code was like all over the place, so it's a lot more modular now. It's multi-threaded, and initially it only had logging to a text file, but the SQL database is supported. Some of the challenges that you face is that to fingerprint an application, it's not an easy process. Like a lot of times, you can parse through exploitDB, but it doesn't contain unique path, because for Yasuo to work, what you really need is a unique path to that application to identify that path. And so like a lot of times what happens is that you end up installing that application or deploying that application to just find out what path is unique to that application. For some of the cases, you can, it could be out there on the internet, so you can use some of the Google Docs to find such applications and then log that path, but a lot of times you have to deploy the application to find out. Login pages, like I said, if it's in English, it can extract the username and password parameter and submit parameter to do the brute forcing. But if in any other language, then it doesn't work that well. Actually, it doesn't work at all. In terms of future development, implemented quite a lot of things. Keep adding the new signature to the tool. But more importantly, I'm working on fingerprinting without port scanning. So for example, because port scanning could be noisy. So working on fingerprinting applications without performing a port scan, and also fingerprinting applications without a particular signature. So these are two things I'm working on and should be able to release a new version end of this month. Again, like if you're using Yasuo, if you come across any signature, because signatures are unique part of applications, are quite the heart of the application. So you can either send me an email or like contribute to it on GitHub, and then like the more the signatures we have in the signature file, the better detection rate it will have. In the end, just a closing note would be, if you have similar applications, first of all, if you're a network penetration tester, a red teamer, or if you're an IT administrator, you can use this tool. It's open source, it's in GitHub, you can download it. And from the defender's perspective, you can run it on your network and then find out what vulnerable applications you have, because it's not easy. Like even generic vulnerability scanners like Nessus don't find such applications. They would find some of the common ones, but not all of them. So you can find these applications on your network and then either remove them or configure them with a strong password. That's pretty much it, if you have any questions.
No, thank you.
Thank you.